Good morning to everyone.
Digital.
Yes, Pranjakta, please go ahead.
Thank you, sir. Good morning, everyone. Myself, Prajakta Bhoite. I am a research scholar of Alana Institute of Management Studies, Mumbai. I welcome you all in today's second session of Path Analysis with Latent Variables with our eminent speaker, Dr. S.M. Fatauddin. Dr. S.M. Fatauddin is known for his vast knowledge in marketing domain as well as he is loved by his students for his lucid method of teaching research methodology, marketing management, and consumer behavior. Dr. S.M. Fatauddin is one of the best performer at IB-SAT All India Test. He has qualified UGC NET twice. He has done his MBA and PhD in marketing from Aligarh Muslim University. Dr. Fatauddin published several research papers in ABDC, SSCI, and Scopus Index journals of reputed publishers like Emerald, Taylor and Francis, Sage, InterScience, etc. He is reviewer of various journals, including AMA, American Marketing Association. His research interests include consumer psychology, green marketing, sustainable consumption, online marketing, internet marketing, and research techniques. He is presently marketing faculty at BIMTech, and that is Birla Institute of Management and Technology. Lastly, I would like to thank our esteemed organizers of the FDP for providing me this unique opportunity to introduce our speaker of the session. And so now, without further ado, on behalf of Department of Management, SMDS, Jamia Hamdard, in collaboration with AICTE ATAL, I, Prajakta, hand over the reins to Dr. S.M. Fatauddin. Wishing you all the fruitful session. Thank you, and over to you, sir.
Thank you, Prajakta. It's an honor to present myself in front of such esteemed researchers and participants. Very quickly, let us start the topic for today's discussion. I am going to share my screen. Please let me know if it is visible to you all. Is the screen visible?
Yes, sir.
Yes, Doctor.
Okay, so am I audible to everyone?
Yes, sir. Morning, sir.
Good morning. So very quickly, this is the topic for today's discussion: path analysis with latent variables. And theoretically, up till now, I hope you have covered what is confirmatory factor analysis, what is structural equation modeling, and before the steps before these two things. Now, let us first discuss what are latent variables. Graphically and theoretically, we will discuss very briefly these two. I hope all of you are already aware about this concept, but just a brief about these two things. First, let me show this particular image. Now, it shows that this is the latent variable connected to three indicators, namely observed 1, observed 2, observed 3, and attached to their respective error terms. You must have seen these kind of diagrams whenever you are performing confirmatory factor analysis or structural equation modeling. So basically, this particular construct, which cannot be measured directly. Taking any particular example, suppose you want to measure consumer satisfaction, employee burnout, role stress, online marketing behavior, online purchasing behavior, impulse buying. So these kind of things may not be measured directly, but through some information that can be gathered directly. Now, those things are called as indicators and also called as observed variables. As per the definitions given by researchers, observed variables, sometimes also called as observable variables or measured variables, which are these indicators, or sometimes called as, in research papers you must have seen written as statements or items, research items used in the questionnaire or survey instruments. So basically, these items are called as observable variables. They may be in terms of continuous series or in terms of metric values, are actually measured by any researcher. And since we are talking about the structure equation modeling, so if you are working with SEM, there are data that is actually exist in your data files. Okay, I'll show you what are observed variables. Although SEM and SPSS treat them, all of them, as variables, so theoretically you should be aware what are observed variables and what are latent variables. What are you going to measure through these observed variables? Opposite of these observed variables is obviously latent variable, which actually we want to measure through these observed variables. Now in SEM, if you see, this is a typical diagrammatic representation of structure equation modeling. We are trying to basically measure this IP, alt, resembling some constructs or environmental knowledge or NEP or environmental attitude. Now these are called latent variables, measured by these observed variables attached to their error terms. So this is a typical confirmatory factor analysis model. So up till now, I hope you are aware what is latent variable. So we are through with the first part of this topic, which is path analysis with latent variables. Now we are through with what are latent variables. We know what are latent variables. Let us start with basically path analysis. What is path analysis? So I just want to ask one question. Are all of you are aware what is exploratory factor analysis and confirmatory factor analysis? Because I need to know that because we want to draw this confirmatory factor analysis diagram. For that, we should know how to proceed from the initial data processing. I hope everybody is aware about this. Am I audible to you all?
Yes, sir.
Yes, sir. Ji, sir. Yes, sir.
So do I need to explain to you what is factor analysis? I hope everybody is aware about what is exploratory factor analysis and confirmatory factor analysis. Still, let me show you how we proceed in this. Suppose we have a typical data set. Now this data set in itself is, a very refined kind of data set. So whatever analysis I'm going to do will give me absolutely perfect results, almost acceptable results in every fit indices, whatever fit indices we consider. Okay, so I'm opening this data file. This data file is a hypothetical data file, and we'll proceed through very quickly. We will proceed to exploratory factor analysis, then to confirmatory factor analysis to check how we proceed to AMOS. Now I'll let you know how to proceed from factor analysis. Now these all are questionnaire items called as basically observed variables. Okay, so I'm not explaining how I'm proceeding with this factor analysis. So I got my result for factor analysis here. There are some sorts of cross loadings. Okay. So here I got my component matrix and I'll paste it on AMOS. So here I got my pattern matrix builder and I'll paste it here and it will show me
So please share again. Sir, screen share required.
स्क्रीन शेयर नहीं हो रहा है.
नहीं सर, स्टॉप हो गया अभी.
Is it visible to you?
No, sir.
Yes sir. Yes sir, it is visible. Thanks.
So this is
Now-
a typical
now it is.
confirmatory factor analysis diagram, CFA diagram, called as measurement model. I think this has already been explained to you. Okay. Is it visible now?
Yes, sir.
Okay. So let's move to very quickly to the structure equation modeling, also called as path analysis. Now what is the purpose of path analysis? Suppose we want to check how this factor called as a latent variable EB affects purchase intention. This is a hypothetical model. Now this model is required to be first hypothesized based on literature. Okay, suppose in this PPT I have proposed this particular hypothesis, these hypotheses H1, H2, H3, H4, H5. Now I propose that environmental belief impact purchase intention, skepticism belief impact purchase intention, perceived technology impact purchase intention positively, skepticism influences negatively. So when we talk of these kind of hypotheses, where we are talking about whether this influences this or not, or impact, when we try to check one independent variable impact another independent variable, or one latent variable impacts another latent variable, whether positively or negatively, this is a kind of a path analysis. Okay, suppose in between we drop any other variable, and we have basically some sort of intermediate variable, or called as, then then there is requirement of checking indirect effect. Okay, then we need to see how we are evaluating a path, a variable affecting b variable affecting c. So these kind of hypotheses wherein we are checking whether a particular variable is affecting another variable positively or negatively, this is called as a typical path analysis. Okay, in path analysis we are actually doing two things. First is, whatever the model we have proposed, we are trying to check or we are trying to do model testing. Okay, model testing, hypothesis testing, and sometimes we proposes a theory, so we are testing a theory also. Okay, so path analysis enable a researcher to check the hypothesis, whatever the hypotheses are proposed, and the model, all in all, whether the model is significant or not. So we propose some hypotheses are accepted, some hypotheses are not accepted. Based on that, we propose that these variables are not significant and these variables are significant. Now, significance of these kind of things, or variable or model, are based on some indices or some values. So let us start with how we proceed this thing. Okay, so I'll show you. Now suppose this is the model I have proposed to you, and this is a model which is been drawn by the researcher. Is there a requirement that I need to show you how to build this model in AMOS, or all of you are aware about how to draw model in confirmatory factor analysis? If there is a requirement, I can explain it to you how we can manually draw this particular diagram. We have ample time for that. If all of you agrees, I can explain it to you that how we draw this diagram on AMOS. We can draw, as I have told you, we can draw it from results of exploratory factor analysis, or we can draw it manually. So let me just give me the opportunity to explain it to you. How can we draw this model on AMOS? I just want to know the moderator whether is there a requirement to explain it to the researchers available here in the meeting, whether we have covered this aspect.
It is being covered, but if it is being required, they can raise their voice.
So somebody has asked me in the comment chat about how to draw from exploratory factor analysis. So see, these are the results of exploratory factor analysis. Okay.
You please repeat it, because they may not
Okay.
able to understand.
So suppose this is my data file. This is my data set. First of all, what you need to do is that you have to feed data here in this data view. You have to define variables here. These are the observed variables for latent variable environmental belief. So I have coded it to EB. These are the observed variables for the latent construct EC called as environmental concern. You can give any code to it, okay, based on your level of evaluation. Only thing what you cannot do is that you cannot leave spaces here. Suppose if I want to write EB2 space 1, I cannot do that. The software won't allow it. Second thing is that you can write language here for these items, which is called as label. Suppose I believe in saving the environment. So this language, it will show in the analysis part. What I recommend is to try to keep two data files. One is as your master file, wherein you are labeling every item. For analysis purposes, try to remove all the labels and try to copy either code or leave it blank. Okay. These are the values attached to it. Whatever the coding which you have given to them. Suppose I have taken a 5-point Likert scale. 1, 2, 3, 4, 5, defining 1 as strongly disagree and 5 is strongly agree. All are scale measures. This is the nominal data, which is requires of family monthly income, educational qualifications of respondents. So this data, it belongs to the respondents. I have taken the sample size of, suppose the data belongs to 212 respondents. Fine. So data feeding is done now, and I'm moving on to the results of exploratory factor analysis. I'm telling you how to proceed to AMOS for path analysis through exploratory factor analysis. I'll go to analyze, go to dimension reduction. Basically, factor analysis is a data reduction technique, also called as dimension reduction. And you will find it in the analysis tab here, and you will go to dimension reduction, then go to factor. I'll reset here. I'll start from the fresh. See, select all the items. So these are all of my items, and put it in the variable box. Now go to the descriptives. There are some indicators which are required to check whether our results are good enough or not. This KMO will tell you. I'll click KMO and then continue. This KMO value, KMO and Bartlett's test of sphericity, will tell you whether the sample size for this analysis is adequate or not. The value, some researchers say that the value for KMO should be greater than 0.7. Some researchers say that the value should be, if the value is greater than 0.6, it is good enough. So you can take any of them, but you need to give proper reference to it for the researcher's name. Then you will go to the extraction part, and then you have to choose any kind of method, maximum likelihood, principal access factoring, or principal component, or any of these. I am taking principal component analysis. You can take principal access factoring also. There will be no difference to the results. Fine. Now we extract items on the basis of eigenvalue. Eigenvalue is defines for those latent variables having a value greater than 1 will be considered as a typical latent variable. So it will help us in extracting constructs based on the observed variables. Suppose I have taken 20 observed variables, or also called as items, and I want to see how many latent variables or constructs are coming from these 20 items. There are chances that it will convert those 20 items based on the level of understanding of the researchers, how they have responded to the items. Some respondent may feel that this is a example of 2 construct, or they are reading it as a 4 construct. So software will read it on the basis of respondent, and on the basis of coding which you have done, the software will extract constructs. So I'll take one value here. If I want to extract a exact number of factors, suppose I want to extract 4 variables, and I believe that it should always give 4 factors. So I'll fetch 4 here. Okay, but generally what we do is that we extract construct on the basis of eigenvalues. This concept is given by eigen, so named on this is named on that researcher only. Okay, now these are maximum iterations 25, which means maximum possible combinations, the best combinations given by this particular software. I'll press continue here. Then I'll go to rotation. Rotation basically is a technique with after maximum iterations give you the best set of commonalities and factor loadings. I'll tell you what are commonalities and what are factor loadings. So suppose if I am I am using any tool and I don't know how should I handle this tool, how should I hold this tool, and I am trying alternate positions, that can be considered as a rotation technique. So rotation technique through all iterations and simulations will give you the best rotated matrix and best set of factor loadings and commonalities. Varimax rotation, direct oblimin, Cortimax. Statistically, I'm not going into the details of why Varimax is being used extensively or oblimin. What are the core stats behind it? Just you need to do is that Varimax rotation is one of the most widely used rotation analysis technique. You can use oblimin also. If you alternatively apply these rotation techniques, you will find difference in the factor loadings. I suggest you start from Varimax, and later on when you started learning the core stats behind it, you can learn when we use Cortimax. I'm not starting it here. Just click Varimax here and continue. Leave the score part, go to options and press sorted by size. It will sort all the factor loadings from higher to lower. I'll suppress a small coefficient. See, I believe that as a researcher, we believe that, and it is suggested by researchers that all the indicators or all the items need to have a minimum or a threshold level of factor loading. And those factor loadings which are lower than 0.5 should not be included in the factor analysis. So what this software will allow me, if I choose here 0.4, it will automatically remove those values which are lower than 0.5. I can choose 0.5 also, but sometimes such as say that go for 0.3. Let's take 0.4 and then press OK. You need to remember that I have only taken the data which is based on some sort of scales. I am not taking nominal data here. I am not taking age here. I am not taking educational qualifications here. So whatever the data has been taken is based on some scale. Okay, scale means which is based on the, as far as the measurement is concerned, is following nominal scale. So nominal scale, we have not taken it. We have taken only scales which are based on some interval or ratio kind of a thing. Fine. Now, if you see here, we have the value of KMO, as I have told you, that it should be greater than 0.6 or 0.7, whatever the researcher are you following or whatever the reference which you have taken. Now we have around 0.774, which suggests that the data is adequate for this particular study. It should be significant as well, and it shows that it is significant because we have taken 95% of confidence interval and it is less than 0.05. Fine. Now these are commonalities. Now another thing which is required to be checked here is that the value of commonalities should not be less than 0.4 ideally. So here if we see, all the values are greater than 0.4. The lowest value is 0.509, which is also acceptable. If you see, if you try to compare commonalities with the factor loading, you will see that the statements or the items having low value as well. Okay. Now here you can see it's showing that extraction method, principal component analysis. Now based on eigenvalues, 6 factors has been extracted by this data reduction technique. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Those factors having value less than 1 won't be considered as constructs extracted by this particular software. This is called as total variance, and it's a very good variance. It explains that this particular these particular scale and the phenomena which we are measuring has been explained um, by a percentage of 68%. That means 68% of phenomena has been explained by these six constructs. It means there are chances that there are some other variables which we have not taken.
Sir, your voice is not audible, sir.
This PI2 item is loading on one first construct as well as fifth construct, as well as here EC also is loading on three construct, 1, 5 and 6. Ideally it shouldn't be like that. Ideally it should be like this. Every item should load on only one construct. Herein you see that every item is loading on its intended construct, intended in which we have proposed and we wanted the results like that. Now if you do it on practically, if you try to collect data based on respondents, whatever the responses you have received from the respondents, you will on the first go you won't find this kind of result. Okay, you need to do some data refining. You need to know, remove the outliers. Maybe you need to check what are the partially fed responses. Maybe you need to remove biased responses as well. So I am not explaining to you how we go for scale refinement and data cleaning. I'm just, since I've already told you, just to minimize the wastage of time, I have taken a ideal set of responses. So this is a typical rotated component matrix. Here you see that based on 6 iterations, based on 6 combinations, and using Varimax rotation with Kaiser normalization, these are the results which we have received. So this is the work up to exploratory factor analysis or factor analysis. Okay, from here we move to AMOS for confirmatory factor analysis or path analysis. So moving on to AMOS, what I need to do is that first I copy this rotated component matrix and I'll go to analyze. This is the easiest way to do that. I can manually draw on AMOS also. I am going to tell you initially, I suggest all of you to don't draw it manually. Go with this method of copying the rotated component matrix. It will ideally give you the best modification indices. Okay, because if you are taking the sufficient amount of loadings here in factor analysis, 0.8, 0.7, 0.6, see, all the loadings are good enough. Only this loading SQ2 is low. I can remove this if I believe that I am taking those items having a factor loading of more than 0.6. But researchers have taken a value of more than 0.5 also. So these factor loadings, these are factor loadings basically, 0.83, 0.82 factor loadings for these items for this particular construct. I have not named here because we cannot name these constructs here in factor analysis. I will name these constructs in CFA or AMOS. So I'll very quickly move on to CFA. I'll copy this rotated component matrix and go to AMOS. You need to incorporate AMOS by installing AMOS in your system. It will automatically reflect in your SPSS analysis part. Okay, now this is a typical interface for AMOS, and file, edit. These are the heads for that. I'll go to plugins. This is the pattern matrix model builder. when you download MOS, you won't find this pattern matrix model builder. For that, please go to YouTube and check the videos of a researcher, and he will explain it to you from where you can download this pattern matrix model builder. Okay, there are some famous researchers whose videos will suggest you how to download this pattern matrix builder. And apart from that, we can have several other plugins like Erase or this Magic Clean, this validity and reliability test. Generally, you won't find this in a default MOS software. So I'll click pattern matrix model builder. So this kind of thing will comes up, and I'll paste the table, the rotated matrix, because it has given me the best results, and I'll create diagram here. Is it visible to you?
Yes, sir. There was one question, sir.
What is the question?
Sir, the thing is that we want to download this plugins. There is any site, a particular site for that?
Yeah, there is a site. I'll let you know in the end of the session. I'll suggest you.
Okay.
Basically, there are researchers called as Gaskin, and he has a very vast set of downloads. You can go to Gaskin, Gaskination kind of. I will provide you the link also, and you can. There are YouTube videos on the portal of Gaskin site. He'll suggest you how to download, where to save it, and how it will reflect on your MOS software. All fine? Am I audible?
Yes, sir. Yes, sir. Yes, sir.
Okay. So we were discussing this. Now, see, ideally, if I draw based on the results of my exploratory factor analysis, see, the software will draw, very comprehensive and very good looking kind of a diagram for me. So now here I can define, this is my variable. I'll just double click it, and it will show me variable name. From one I can save, I can give any name. Suppose I can name EB because it is environmental belief. And I click here. I can name SK because it is skepticism. This is PI. This is PT. This is KM. And this is EC. One thing which I should tell you, that this is a hypothetical data set. This is a hypothetical model. So you need to name according to your data set and your theory which you have proposed. Okay. Now, next thing is that I need to select my data file. It will automatically choose. How can I save this icon? Basically, if you see, if I move cursor to it, it will show me select data file. Select data file. If I select from here, I'll choose. I'm working on it. Now I need to save this. So this icon will save this diagram, and it will ask me from where should I save this. I am saving in this my test folder. Suppose I have same test _ CFA. You need to save it before opening it. I save it. Then I'll go to analysis properties. I'll go to output. I'll choose some indices which are required to be tested. I'll click standardized estimates. I could motivation indices and residual moments. I'll click OK. And then I'll go to calculate estimate. So sometimes MOS do this to us. So I'll restart the save. So tests or CFA. Okay, so now if I choose the data file, this is the data file. I press OK, and then I'll calculate the estimate. From this particular icon, this view text icon, I can uh, show my results to you. Now this is the nodes for model, and it should be significant. Okay, it will help in testing me the appropriateness of hypothesis. Chi-square is also minimum. Chi-square is achieved. Degrees of freedom, based on degrees of freedom, we can achieve chi-square over minimum, which is I'll show you in the next aspect. Now, these are the results of CFA. This is a value. These values generally we see. The first value which we see is whether the value of this CFI, which is a fit index, is greater than 0.9 or not. Okay, so this is a very good value of CFI. This is GFI, which we generally see. These values should be greater than 0.9. If they are greater than 0.9, the values are very good. Even generally researchers say that it should be greater than 0.95 for ideal kind of a value, but we accept a value greater than 0.9 also. Sometimes researchers say that average model will give you a value of greater than 0.85 as well, but a value greater than 0.85, less than 0.85 is not acceptable, and it will be considered a very poor kind of a fit index. So there are several kind of fit indices. I am not explaining to you what are various kinds. Just remember what we see and what we report. GFI, this is absolute GFI. This is CFI. Next thing which we see is RMSEA, root mean square. It should be less than 0.06 and it is 0.04. It is evident. This is P kilos. It should not be significant. Remember, it should be greater than 0.05. So it is 0.883, which is also good. So the model reflects that this is a very adequate fit. If the results are not good, we then go for checking out how these error terms are related or not. We do some statistical changes to our model, but currently the model is good enough, so I'm not going to explain it to you what we generally do to check. Fine. So these are the results of what we say is that confirmatory factor analysis. Confirmatory factor analysis suggests that whatever the construct explored by factor analysis are confirmed by confirmatory factor analysis. From here, we move to path analysis. Path analysis for testing our model which we have proposed and testing the hypothesis as well. So we can start from here also. Suppose if I want to, for that I need to check first is what is my model. Now this is my model that these variables directly influence purchase intention. Positively, some negatively, skepticism negatively, because based on theory, I think that skepticism negatively influences purchase intention. Fine. Rest, knowledge, environmental concern, perceived technology, environmental belief, these positively influence purchase intention. So do I need to explain how we draw? I can just move those variables. Suppose very quickly I explain it to you how we can move those variables. So first of all, I need to remove these covariances. Okay. And then I choose this train kind of icon, which suggests that move objects, and I'll select this preserve symmetries. If I choose this train kind of icon and this choose symmetries, and if I go here and I click and I try to move every whole, this construct will move. Okay. So here all the environmental belief, skepticism, PI, PT, KM are independent variables, latent constructs, and this in purchase intention is dependent variable. Rest are independent variables. So I'm not touching the independent variables. I can move here only. I can rotate this as well, like this, or I can, just using this train, I can. Fine. If these, if I have drawn it manually, uh, it looks a bit distorted. So I could have used this magic clean, and if I click here, it will give me, see, I have used magic clean and it is, drawn it very perfectly. मैजिक क्लीन इज इट, मैजिक क्लीन जो दोनों चीजें करता है, टचअप भी कर देता है और डिस्टॉर्शन भी खत्म कर देता है. यहाँ पर जो करेगा खाली टचअप करेगा. यहाँ से अगर मैं मैजिक क्लीन, इफ आई डाउनलोड मैजिक क्लीन फ्रॉम गैस्किन साइट, it will do both the things. Fine. Then I need to draw this thing that see, there are a few propositions or assumptions to path analysis, and these arrows explain these assumptions. This arrow explains that this particular variable is explaining this variable. It means this independent variable is basically explaining this dependent variable called as purchase intention in a unidirectional way. These relationships are linear and additive. Linear means they have a linear kind of a relationship. I am using a linear model. Basically, structure equation modeling using path analysis is nothing but multiple linear regression. So whenever we want to use multiple linear regression having one or more than one dependent variable, and we want to consider error terms as well comprehensively, then we go for structure equation modeling. Basically, when we can do these things on SPSS as well, but when this is a very simplistic kind of what we say as a model. I'll explain it to you whenever there are complex models, like when we are using mediation technique, moderation technique, or indirect kind of a model. I'll try to check through an indirect model as well. Okay, then we cannot use MOS or SPSS. For that, we need to do regression analysis using SPSS twice or thrice. Okay. I hope it is clear up till now. Fine. Now PI is a dependent variable, so I need to put some regression weight to it. This icon will give me regression weight, and I'll drop regression weight to it, and I'll need to name all the unobserved variable. Since regression weight is also an unobserved variable, so from this plugin I'll name unobserved variable. So E21 has been named by the software because up till 20 has already been named. Fine. Now you can choose your data file as well. Okay. And you need to save it as well. Again, you need to save it. And suppose I'll save as a test underscore SEM. I'll save it. Fine. Then you can go for analysis properties. We have already chosen all the analysis properties, and then I'll go to calculate estimates. Okay, so I can proceed with this analysis, or sometimes we need to, although it is not mandatory, I need to basically table, but it is so how can I proceed? I click these independent variables using this particular icon, this finger icon, and I have chosen 5, and then I need to check name unobserved variable. Then I'll need to draw covariances and then deselect all. This icon will deselect everything. Okay. Before that, before proceeding to SEM, for path analysis, what you need to do is that the results of CFA are required to be validated. Now, how they are validated? I have see they are validated. These are the results of CFA. Fine. It will show you like this. These are the CFA loadings. Okay. These are the value of covariances. And they will be checked based on some indices. These I have explained it to you. It should be greater than 0.85, 0.9. RMSE should be less than 0.0.
So you're not audible, I suppose. Dr. Fatah, you're not audible to us.
I think there is some network issue at the end of the resource person. He'll be connecting soon.
Okay, so there was some connectivity issue. I hope Dr. Asad, am I audible?
Yeah, you're audible now.
Okay, so what was the last topic which we have covered? Because when the video got disconnected, I may not remember. So
You have
do I
added
have
21.
you have okay? We have added 21. Fine. So we have added this error term. Fine.
Yes, sir.
Okay. So now for further moving further, what we need to do is that we have to draw covariances for these independent variables. We need
Dr.
to
Fateh,
covariate.
sorry to interrupt. Your
Yes.
screen is not visible to the participants. Can you share the screen?
Is it visible now?
Not yet.
No, it is not visible.
Yeah, it's fine.
Yes, it is.
Okay, so we have given a error term to the dependent variable. Whenever we have, suppose we have one dependent variable, then we need to add one error term to that variable. When we have more than one, then all dependent variables we need to have one error term. Fine. Error term will be based on this regression weight. This is our regression weight. We have given error term based on this regression weight. Fine. Now these are independent variables, and these independent variables needs to be, covariated. I need to choose here, and then I'll go to this plugin, draw covariances, connect all the. I can proceed without covariating them as well, but some researchers say that you need to covariate all the 5. This is not, there's no consensus with it. I can proceed, drawing covariances, or I can proceed without covariating all of them. Now, before that, what we need to do is that we need to check the results of CFA which we have obtained. Okay. Now, for our CFA model, this is our. What I'll do is that I'll disconnect. Fine. Now, so
you're not disconnected, sir. You are okay.
Now, in the MOS, if you go to this validity and reliability test plugin, this will be available when you download it from Gaskin site. On a default MOS version, you won't find this validity and reliability test plugin. Fine. So download it from that particular site, and after obtaining the CFA results, just click this validity and reliability test, and you will be able to receive this kind of a table. I have just pasted it on PowerPoint. You will get this kind of a table. I'll explain it to you what it depicts. This is CR, called as a kind of a reliability for confirmatory factor analysis, construct reliability. Fine. Just like exploratory factor analysis, where we have Cronbach alpha for testing the reliability of the scale, here we have construct reliability. So CR test the reliability part of CFA results. The value should be greater than 0.7. Researchers say that, and it is evident that for all the constructs, the value is greater than 0.7. It is 0.8, 0.849, and the lowest value is 0.726. So we can say that there is, apart from internal consistency from Cronbach alpha, we have construct reliability as well. Now, moving on to the validity part. For validity, we need to check two kinds of validity. First is convergent validity, and second is discriminant validity. So I explain it to you what is convergent validity and then what is discriminant validity. Convergent validity means whether the construct which is intended to be measured is converging or not, or the amount of variance extracted by the construct is convergible or not. So now amount of variance has to be decided by some value, whether amount of variance is explained or not. That has been defined by the value of AVE, called as average variance extracted, and this is the average variance extracted for environmental belief. Researchers say that the value for AVE, for depicting that it is having convergent validity, it should be greater than 0.5. Now, if you see that for EB it is good, for PI it is also good, for SK it is also good, PT is also good, KM is also good, but for EC it is less than 0.5. Now you need to give some justification to it, why the value for AVE is less than 0.5. I will be having a different justification based on my study. Okay. Maybe the study is of exploratory nature, so we can say that this is a first of its kind. That's why it is lower than. Researchers say that for exploratory study we can accept the value greater than 0.5 as well. But generally, it should not be less than 0.5. So this is a hypothetical data. So any value can come up. Now these values in diagonal, which is in bold, I have highlighted it, suggest discriminant validity across. Now forget this CR part. Forget the CR part. If starting from AVE to EC across the rows and columns, this value should be highest. This value should be highest. Now, if you forget CR, 0.715 is greater than 0.511 and also across the column. Similarly, for PI, when these values are higher across rows and columns, we believe that we have discriminant validity. Discriminant validity means how a particular construct is different from the rest of the constructs. How EB is different from PI, SK, PT, KM, EC. Because we believe that EB is different from PI. We believe EB is different from SK. We believe EB is different from PT, from KM, and from EC. Similarly, from PI, we believe PI is different from rest of the under this study. So discriminant validity can be, if you try to check the under root of this value, you will find the value is 0.715. So here, in both ways, we can calculate from AVE also or from the plugin also. This plugin validity and reliability test. Then we can move on to the MOS part, which is path analysis. So we have drawn path analysis, we have saved the file, and then we can calculate the estimate for it. And now we have our results. This is the view text part, jahan se hum where we can see the results. See, you will see that whenever we are taking same number of variables in SPSS, in MOS for CFN and basically SEM, the generally probability level and a chi-square values remains the same because the degrees of freedom remains the same. We are not discussing it, just explain it to you. You will see that CFN, MOS values are same because we have taken same number of variables and the relationships are same. Then we move on to the model fit. Again, the values are good enough. Then we go to the estimates. Now these things are required to be tested. These values, estimate, SCCRP, explains our SEM, our structure question modeling, simple or multiple linear regression, and path analysis as well. This value, this estimate value, explains whether the relationship is positively related or negatively related. Explain it to you. Then this p value, this is significant or probability value, will explain it to you whether these relationships are significant or not. I hope all of you are aware, since we are testing at 95% of level of significance. So the value should, for getting the relationship significant, the value should be less than 0.05. Okay. Now here you see this star means the value is 0.000. Fine. This value is 0.002. The rest of the values are 0.13, 0.15, 0.342. It means these three values are not significant. Fine. This negative sign means, see, if you remember, we proposed that skepticism negatively influences purchase intention. So the negative sign suggests that it is having a negative influence or a negative relationship with the dependent variable. Fine, but it is not significant. So our hypothesis is partially supported, but actually it is not supported, because if it is, it will be considered as supported or accepted if this value is less than 0.05. So path analysis suggests that this path is significant or not, this path is significant or not, this path is significant or not. this part is negatively significant or positively significant. Again, if you try to validate it through our part diagram, then what you can do is that you can click here and you can go check the standardized estimate. See again, this SK, if I zoom it out, this SK is showing a negative value of beta minus 0.1. So whenever you are writing a research paper, then you need to paste this diagram to validate your result. You need to copy file and you need to copy from the edit folder tab, copy to clipboard, and you can paste it on your Word file. Fine. These are the factor loadings. Remember, the factor loading should not be less than 0.5. This value SK2 is having a factor loading of 0.42. So for further analysis, for improving the value, we can remove this as well. So I'll show you how we can proceed by removing this value. Suppose if I remove this and I'll again test it. I'll check the estimates. So this value was initially minus 0.15. It has been reduced to minus 0.11. Fine. Even the model fit is also improved. The value was for CFI was 0.963. The value for GFI was 0.916. So both the values has also improved. Fine. Even the value of P close, if you see, initially was 0.88. Now it is 0.957. For RMSA, it was 0.04. Now it is 0.03. So the values improving if we remove the outliers. These are considered as outlier. So this is simplest model. Where path is become significant. Suppose if we have a complex model, if I remove these relationships, and theoretically we propose that suppose these skepticism, perceived technology, knowledge, and environmental belief influences environmental concern. Just let me draw it for you. If I move this here and this one here, if I rotate this, fine. If I move this here to just make it more spacious. Fine. Now I'll explain it to you how this model path analysis become relevant. See, now for testing this model on SPSS will require two steps. Twice you need to go for regression. First, you need to check the impact of these four on EC, and then you need to check the impact of EC on PI. Fine. So, but as MOS allows you to use these kind of complex models on, you can test these complex models at one go. Sometimes we have these kind of relationships as well. Suppose this environmental belief act as a moderating variable. Diagrammatically, this should come here between EC and PI, just explaining it to you for theory development. Sometimes we have some moderating or mediating variable as well. Or suppose probably any model like this, we can have. So sometimes we have this as a mediating variable or moderating variable. So this cannot be tested at one go on SPSS. For checking all these things at one go, SEM allow us to use these kind of models to test these kind of relationships through path analysis comprehensively. Fine. How we do that? I'm not explaining to mediation and moderation, just checking and explaining it to you uh, indirect model where we have indirect relationships. So we have tested direct relationships. Now let's test our indirect model. Now this is another model which can come up to you. Now can anybody explain what are various kinds of dependent variables here in this model? What are various dependent variables? Can anybody explain?
Am I audible, sir? Hello.
Yeah, you are
Yeah.
audible.
Sir,
Yes, you are audible.
EB, SK, and PTK are the dependent variables, and independent variables are EB2, EB1, 4, up to the EB13. That is the dependent and independent variables. And
No. You are. I think you are confused. You are a bit confused, I think. See, EB, SK, PT, and KM are independent variables for EC. So EC becomes a dependent variable for these four: SK, EB, PT, KM. EC becomes a dependent variable for these four. Fine, it is clear?
yes, sir.
These four become independent variable for EC. As far as PI is concerned, PI will become a dependent variable for EC. So EC will become an independent variable for PI, which was actually a dependent variable for SK, EB, PT, and KM. Now again, just like the previous analysis, we have given some regression weight to the dependent variable PI. Here also, we need to give a regression weight to this EC because it is also a dependent variable. And again, we need to name this unobserved variable. Then we can proceed to, I am just proceeding with the analysis. I'm not covariating. Now going to the results, model fit is significant, fine. These values are also significant. GFI is a bit low, but acceptable. RMSEA is also acceptable and P close is also acceptable. We will quickly move on to the estimates. Now, if you see, this SK is not influencing EC. Rest of the relationships are significant, which suggests that I'll again go to the model. See, this relationship SK to EC is not significant, but rest of the model EB is influencing EC. We'll go to the results. EB is influencing EC and EC influencing purchase intention. Now, if I remove this SK from here to further get a clarity, EB, PT, and KM are influencing environmental concern, which further lead to a purchase intention. This is a typical, example of a path analysis where you are creating a path that this is affecting this and this further leads to purchase intention. Theoretically, we build these kind of models that environmental belief influences environmental concern, and those consumers having a conscious environmental concern will affect their purchase intention. Similarly, consumers having a perception regarding the technology of a product, a green product probably, will have a significant impact on environmental concern. Their concern for the environment will lead to purchase intention. Again, the knowledge of using a green product, or let's say a product like an electric vehicle, will develop a consciousness about environment, and it will further lead to purchase intention. So this is a typical representation of what is called as path analysis. If you need to see, let me proceed with the analysis. I'll check unstandardized estimates here and I'll zoom it for you. See, all the beta values are positive. It means every path is positive. And the theory says that these kind of relationships are required to be recursive. What is the meaning of recursive? It means that it should not be a bidirectional relationships. These relationships should not be bidirectional, but these relationships should be unidirectional. What is unidirectional? It means that EB should influence environmental concern. Environmental concern may influence purchase intention, but it shouldn't be like purchase intention influencing environmental concern and environmental concern influencing environmental belief. It shouldn't be like this. So these models are recursive, unidirectional, linear, and additive. So these are the assumptions of path analysis. These are linear relationships, no quadratic, no logistic, no exponential. These are linear relationship. If this varies, this also varies linearly. If this varies, this also varies linearly. Okay. This influences environmental concern, but environmental concern doesn't influence environmental belief. Okay. Similarly, these are sometimes called as additive effects are there. Okay. These are not multiplicative effects. These effects also, uh, whenever these two effects simultaneously, the results will be different. If you drop this, results will be different. So presence of one variable affects the presence of the other variable. That's why it's called as additive, linear, recursive, and unidirectional. These are the assumptions of path analysis, and path analysis assist us in analyzing whether one variable is significantly or positively or negatively influencing the dependent variable. This is a latent variable, this is also a latent variable, and these are observed variable. So I hope I have explained it to you what are latent variables, how we take data from SPSS file to MOS. So if there is any query regarding CFA, regarding AV values, we have ample time to discuss those issues.
Sir, may I ask a question?
Yeah, please go ahead.
On the last model, I want to ask the EC2, why is it a double-sided arrow?
Where is it?
If you just go back to that model where it was showing.
No, actually
Here.
it is not
So
double.
EC3, EC3.
Yeah, okay. So basically it is not double-sided. Basically
Here
it
we
is
have
overlapping.
EC3.
This is overlapping. This is overlapping. See, this is it. It was looking like this. What is was looking. These are two different. This is error term, overlapping environmental concern.
Okay.
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 It was showing like this. Was error term was overlapping.
Okay, so that's why EC3 was showing a double-sided
Yes,
arrow.
it was like it is like this basically. You are seeing it like this. Fine.
All right. Okay. And this is actually where we have the circles outside. Those are the data entry points, aren't they?
Where is data?
Sorry, you have an arrow on the other side of the box. That's the data, right?
This.
Yes, these small circles.
These small
So we
circles.
have E20, E19, E18.
No. Basically, see. Now, okay, I'll explain it to you by drawing manually. The question is asked by the researcher is that whether these E1, E2, E3, E4 are the data labels. No, these are not data labels. Data labels are this E1, E2, E3, EB1, EB2, E3.
Okay.
How we do this? Let me explain it to you. I'm just removing all these. How we draw these manually, it will make more things more clear to you.
Thank you, sir.
But I suggest all of you to try to learn drawing this model from the results of EFA, because better the results of EFA, better the results of your model. Fine. So these are the icons, helpful icons for
Actually, I did try drawing the model once, but the problem was I could not understand what the circles were for. I got the data
Fine. So,
also entry and I couldn't
so
generate the results then.
I am explaining it to you how we draw it manually. Fine. So first of all, I have clicked an unnamed project and I have chosen a new template. Fine. Then I'll go to my data set and I'll choose my data set here so that data can available here. Then I'll go see these are the icons which will be helpful for us to draw these diagrams. So this is this icon, the third from left or the first from right. I'll click it and I'll just click it and I'll just press it. Just what size of the icon I want to draw. Typically, this is the adequate size for labeling our construct or little construct. Then I have drawn it. I'll click it. I'll click it. The number of observed variables for that particular construct I have. Suppose if I again go to my data set in SPSS, in this variable view, see for EB we have EB1, EB2, EB3, EB4. We have 4 statements for EB. So I'll go to this file and I'll click 1, 2, 3, 4. Fine. Is it clear? Is it clear to you?
Yes, sir.
Rest of the constructs have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. Rest of the construct have 3 items. So what I'll do is that I'll very quickly, I'll just click this 1, 2, 3, click 1, 2, 3, click 1, 2, 3, click 1, 2, 3. Number of constructs I have. I can rotate it from this icon. The better the learning will be if you have your own data set. If you have your own data set and you try to draw based on your data set, based on your questionnaire responses, the more you practice it by using your data set, the more you will be able to learn how to do it. If you just keep on watching the videos and tutorials, let me explain it to you, it won't help that much. For better learning, just keep your data with you and then the tutorial and then start practicing. Fine. So I have drawn for 5 variables just for your explanation. Then I'll align it by clicking this cleanup touch-up variable icon. From this train icon, I can move, aligning with the, looking at more, comprehensive. Then I need to fill these data variables, from where this icon list variable in the data set will give me the list of my data. See, these are the list of my variables. EB1, EB2 up to the demographic as well. Demographic will be required when we were doing some kind of analysis based on our demographic variable like moderation. Okay. Now I just drag it from here to in this box. EB1, EB2, EB3, EB4. Then for EC1 I can just drag it to the box. Then you can drag it for the rest of the construct as well. Similarly for PT, PT2 and PT3, and let's take PI. If you have a larger number of constructs, then what you can do is that you can change the layout of this analysis part. How you can change the layout? We have several interfaces for this. We can go to view and we can go to interface properties. From where you can change the layout, you can go to view and you can change the interface properties. Then you can change from here. See, currently we are having portrait letter type of interface. You can take portrait legal as well. It will give you a comparatively longer column. If you want to do SEM analysis, you can move on to landscape. Landscape will broaden. See, it is broadening the view. For CFA, you can go to portrait basics, depending upon the depending upon the number of constructs you are having. Constructs. Now, this represent error term associated with every item. This is the comprehensive nature of SEM MOS, that it considers error terms as well while we are analyzing the results for uh, confirmatory factor analysis or MOS. This is a advantage of using MOS, that it considers error terms as well, which is generally not provided by SPSS. So that's why we move from SPSS to MOS. This is also one of the reason for moving on to MOS. Now, as I have already told you, that in a default model, you will be having this name unobserved variable plugin. Just click it. See, all the things which are not named will be named by the software in itself, even from E4, E2, E1 to 14, because there are 14 observed variables or items or indicators or statements from your questionnaire. Now, based on your decision, you can name anything to it. As I've already told you, you can name EB because the items are related to EB for having a better understanding. For EC1, EC2, you can name EC. For PT1, PT2, you can name PT. For PI, you can name PI. This is how we can draw. Again, I'll click this icon and I'll select every latent construct here, and I'll just draw the covariances to further move for confirmatory factor analysis, and just then again deselect every object, otherwise it will not allow you to do analysis. I'll deselect everything again. Okay, so I have not named this one. This is game. For clarity, you can rotate these. Okay, then you need to save this. But you can name anything like, let's say, HAM PDF, HAM test. Fine. You need to rename it, and then you need to go for output properties. You need to select residual moment, modification indices, standardized estimate, and then click analysis. And then if you see these will give you covariances values. These will give you factor loadings. Here you see the factor loadings. If I zoom in for you, the factor loadings for every item is not less than 0.5. For every item, it is greater than 0.5. So I hope that the results given by CFA will provide me an adequate fit.
Thank you, sir.
Okay, so
I understand where we made the mistake. Actually, we could not arrive at the solution because we probably made that mistake in the model a bit. Otherwise, we had also designed it like this exactly. But thank you, sir.
Okay, so this is how we draw for factor analysis, and similarly for just moving on these constructs to in a different layout, and then going for path analysis. So I hope I am clear to you all in explaining what is EFA, what is CFA. Is there any question?
Sir, good afternoon. So my question is
Yes.
object to when you are coming to the latent construct, then latent
Mhm.
construct to another latent construct. Then we are given to the some relationship between to the object latent and another latent. Then again we are going to the path beta value. Am I right, sir? Hello, I'm audible, sir.
Yeah, you are audible. I'm not able to understand your question. You are saying that we are checking the relationship between two latent construct.
No, my question is that suppose there is the object value, then object to we are given to some factor, whatever called it is the latent construct, then
Yes.
latent construct to another latent construct, and we are giving
Yeah.
to the some relationship through the path that is the beta value. Am I
Yes.
right, sir?
Yes.
Sir, my question is that if beta value is higher in compared to the other, what does it meaning for that? Suppose beta
See,
value is
okay,
0.35, 0.45. Yes, sir.
let me explain you on the best of these results.
Yes, sir.
See, these are the results of MOS, SEM MOS. Now, if you see these estimates give you direction, the negative or positive relationship between variables.
Yes, sir.
Now, if you see, if the value of this value, estimate value starts, increasing, if the value start increasing, it started become positive.
Yes.
Sometimes, obviously, beta value, the negative value, the greater the negative value will give you a definition that it is impacting, having a strong negative relationship between dependent and independent variable. The value, if the value is positive and higher value is positive, we suggest that that they are having a stronger positive impact between the independent and dependent variable. Similar to correlation, that the higher the value of correlation, positive correlation, we believe that up to the value of 1, isn't it?
Yes, sir.
So this value will reach obviously up to the value of 1. Why it is, we can say that it will reach a value of 1 because see, this EB2 can reach up to the value of 1.
Sure.
Okay, but generally we don't fall for whether the value is higher or not. We want to check whether our hypothesis is supported or not. So we see based on the direction and the value of p value whether our hypothesis values are coming significant, or what is the direction of the hypothesis, whether it is positive or whether it is negative. Sometimes we don't propose the direction to our hypothesis. We generally propose that this A, or the job satisfaction directly influences employee turnover. Okay, we generally propose, but sometimes we don't propose that whether positive job satisfaction or negative job satisfaction impact employee turnover, or stress impact employee job satisfaction, or training impact employee workout. So sometimes we don't propose directions to it. This is based on our model and based on our theory. What we generally check, we check whether this, if we are proposing that we are giving some direction to it, whether it is negative or positive, or whether it is significant or not. First we check whether it is significant or not, and then we check whether the direction coming is according to what we have proposed or not. I hope this is the answer of the question.
Hello, sir.
Yes.
Hello. Sir, just a question on the basis of direction of the our propositions. Like in your example, skepticism is negatively influencing purchase intention. So, sir, checking directions. So we need to do something or not. Like if I am proposing negative relationship between any variable. So how our model this almost automatically calculates that thing, or we need to do something?
See, AMOS will automatically calculate everything. You need to check whether the results provided by the AMOS are according to what you have proposed or not. Fine.
Yes, sir.
And whatever you are proposing should be backed by literature, should be based on some theory. You cannot propose anything like you cannot propose any radical statement, isn't it? You cannot propose that something which is not actually possible. But obviously there is a general saying about statistics. The general saying is that a statist is a very good slave but a very bad master. So whatever you pose in your software, obviously it will give you some results, but that has to be interpreted by the researcher itself, whether the results are logical or not. You can propose what is backed by theory, what is backed by literature, and what is logical. What according to you is logical may not be logical according to the theory. That's why we rely on theory but not our own brain. Fine. So that's why the importance of research papers and literature review in authentic journals, that whatever we propose is based on whatever has been published in good journals. We rely on those literature. We propose what they have done. We try to innovate what they have done, and then we collect data and then we check results. That's why our results generally come in compliance to what we have proposed. Suppose we have proposed A influencing B negatively, which is practically not possible, and results are also not coming in our favor. And we are saying that we have proposed the results are not coming in our favor, but actually it is not possible. You are collected data from respondents, and respondents are obviously giving some logical answers. Software will take responses and reply based on the responses itself. So we proposed based on our literature, based whatever the literature available in the published articles, and then we propose our model. We check based on this software. Obviously, software will calculate it. Anything which you feed, if it is according to the syntax, it will not providing any syntax error, because SPSS has 4 windows. So you need to go in compliance with those 4 windows. Anything else? Any query? So if there is anything, we can continue, or Dr. Jamshed, because we have another 10 to 15 minutes.
Yes, sir. Any question from the participants, or we can conclude the session? Prajakta? Dr. Prajakta, you're there?
Yes, sir. I can hear you, sir.
Yeah. Please conclude the session.
Sure, sir. Am I audible, sir?
Yes, sir. Very much.
Thank you very much for such enlightening session and informative session, which solved our basic doubts about path analysis and latent variant. So thank you very much, Dr. S.M. Fatah, and I wish you all the best for next sessions, and we will all depart for next session, and we all will meet at 2 o'clock. Am I right, sir?
It's 2:30.
Yes, sir. 2:30. Okay. So we all are going to meet again at 2:30 p.m. for third session, sir. Thank you very much.
Thank you. Thank you. Thank you. Thank you.
Thank you. Thank you, Dr. Fatah. Thanks a lot, Dr. Fatah.
Thanks a lot.
We will resume again.
एक मिनट मेरा सर बॉलिंग भेज दो.
Sir, will we be sharing the feedback link as well for the session 2?
Yes.
Yes, sir.